Today we're going to take a look at section 8-3, trigonometry. The objective in this section is we're going to use sine, cosine, and tangent ratios to determine side lengths and angle measurements in right triangles. Key concept we have to take note of the trigonometric ratios. Given this picture of a right triangle, sine of angle A equals length of leg opposite angle A divided by the length of hypotenuse. So that would be the length of leg opposite angle A. Angle A would be right here. The length of leg opposite angle A would be side A. The length of hypotenuse being C, that fraction would be A over C. So sine of angle A is opposite over hypotenuse, which would give you A over C. So the formula for sine is leg opposite over the length of hypotenuse. Now, if we look at cosine of angle A, that is the length of leg adjacent to angle A. Here is angle A. Adjacent would be side B, which would be on top, over the length of the hypotenuse, which is C, on the bottom. So cosine is the length of leg adjacent to angle A, which is B over the hypotenuse C. Let's take a look at tangent of angle A. Again, starting with angle A, right there. The tangent of angle A is leg opposite angle A. Opposite of angle A is side A over there, which would be going on top. Over length of leg adjacent to angle A. What's adjacent? Adjacent is the one right next to it, which is B, which would go on the bottom. So tangent is opposite over adjacent when you're looking at angle A. These three concepts, sine, cosine, and tangent, will help you solve the next problems in this section. A trick to remembering what these formulas stand for, you can remember SOACOHTOA. You can remember what this means. What I mean by that is you take the first letter, sine, with opposite O, and H. That's what the formula is for sine, opposite over hypotenuse. cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, which gives us the big bad monster of SOACOHTOA. So remember, SOACOHTOA, you can do all these trigonometric ratios. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. So just remember, SOACOHTOA, the big bad trig monster. So let's take a look at problem 1. We are given a triangle with angles T, G, and R. And then we have hypotenuse 17, and we have one leg, 8, and the other leg, 15. Go ahead and write that down. So how does this relate to sine, cosine, and tangent? Well, here we have our sine, cosine, and tangent, which is our SOACOHTOA. Let's see how that works with a triangle trying to find the sine of t. So we're looking at angle T right here, and we want to find the sine of t. So what do we need to know? We need to know that it is opposite. Here's angle T. Opposite is 8. So it's 8 over the hypotenuse, which is 17, which goes down on the bottom. So the sine of angle T is opposite over hypotenuse, which is 8 over 7. If we look at cosine of t, cosine again is adjacent over hypotenuse. So I'm looking at the cosine of angle T. We are looking at the adjacent, which is the leg right next to it, 15 over the hypotenuse, which is the 17, which goes on the bottom. You have 15 over 17. Let's take a look at tangent T. Again, tangent is opposite over adjacent. Looking at angle T, once again, opposite would be, opposite this angle is 8. So 8 is on top over adjacent, which is 15, which you end up with on the bottom. So tangent T is 8 over 15. Just to remind you again, a big bad monster of SOACOHTOA. Okay? So again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Let's take a look at problem 2 using the information that we just know about. If we're given this picture of the Leaning Tower of Pisa, and after all reading this information, we know that it has a tilt of 5 degrees. The height is 150, which is a 5 degrees tilt, and our height is 150 from the ground all the way up. How can we use information that we were shown before to find what is the distance of x down here at the bottom? To do that, we are given angle 5, which is up here angle. So this angle up here. And because they give us the x on the bottom and the 150, actually, we want to find x and they give us 150 as the height, we can use the formula tangent 5. And to do that, we would know tangent is opposite, which is x, over adjacent, which is 150. So tangent 5 degrees equals x over 150. So you would write that tangent 5 degrees equals x over 150. So let's take a look at how we would solve it over here. Tangent 5 equals x over 150. We want to get this x by itself, so what do we have to do? We have to multiply both sides by 150. And what does that leave us? 150 times tangent 5 equals, these two cross out, x. So how do I put this in my calculator? I'm going to take 150 tangent, I'm going to hit my tangent button on the calculator, then plug in 5, and then hit enter. And that will give you x equals 13.123 and a bunch of other numbers, which I can round that to x equals 13.